This topic is about data mining algorithm using prediction. What is prediction? Prediction is a data mining technique that is done for the purpose of using business intelligence or other data to forecast or predict trends. This type of data mining can help business leaders make better decisions and add value to the efforts of the analytic team. It is used to provide business with two main benefits: describing historical data and uncovering meaningful patterns, rules, and relationships across disparate datasets that help predict future outcomes. The Bayesian networks. A Bayesian networks, or BN, is a probabilistic graphical model for representing knowledge about an uncertain domain, where each node corresponds to a random variable and each edge represents conditional probability for the corresponding random. A Bayesian network are also called belief networks or BaseNet. Due to the dependencies and conditional probabilities, a Bayesian network corresponds to a direct acrylic graph, where no loop or self-connection is allowed. A Bayesian network is a probabilistic graphical model that measures the conditional dependence structure of a set of random variables based on the Bayes theorem. The basics of Bayesian network. The Bayesian networks define joint conditional probabilities. It combines Bayesian reasoning with causal relationship between attributes. The Bayesian network is also known as belief networks or probabilistic networks. Bayesian network is defined by direct acrylic graph with node representing random variables and links. Other is conditional probability table. For each variable, for example, probability of x and parents, the probability of each value of x given every possible combination of value of its parents. The other is reasoning. Given the probability of some nodes or the input, Bayesian network calculates the probability in other nodes or the output. The next is classification. The input is the attribute value and the output is class value probability. There are mechanisms for training Bayesian network. From example, given a variable in network structure, creating conditional probability tables.
Instance-based learning method. The machine learning systems, which are categorized as instance-based learning, are the systems that learn the training examples by heart and then generalizes to new instances based on some similarity measure. It is called instance-based because it builds the hypothesis from the training instances. It is also known as memory-based learning or lazy learning. The time complexity of this algorithm depends upon the size of training data. The worst case time complexity of this algorithm is 0, where n is the number of training instances. For example, if we were to create a spam filter with an instance-based learning algorithm, instead of just flagging emails that are already marked as spam emails, our spam filter would be programmed to also flag emails that are very similar to them. This requires a measure of resemblance between two emails. A similarity measure between two emails could be the same sender or the repetitive use of the same keywords or something else. Next is the advantages and disadvantages of using instance-based learning. For the advantages, instead of estimating for the entire instance set, local approximations can be made to the target function. This algorithm can adapt to new data easily, one which is collected as we go. Disadvantages: classification costs are high. Large amount of memory required to store the data, and each query involves starting the identification of a local model from scratch. The k-nearest neighbor learning. The k-nearest neighbors KNN algorithm is a data classification method for estimating the likelihood that a data point will become a member of one group or another based on what group the data points nearest to it belong to. The k-nearest neighbor algorithm is a type of supervised machine learning algorithm used to solve classification and regression problems. However, it's mainly used for classification problems.
The next topic is the linear models. Linear models are a way of describing a response variable in terms of a linear combination of predictor variables. The response should be a continuous variable and be at least approximately normally distributed. Such models find wide application but cannot handle clearly discrete or skewed continuous responses. Basic idea of linear models. Work most naturally with numeric attributes. The standard technique for numeric prediction is a linear regression. Predicted class value is linear combination of attribute values. Example, the C is equals to WO times A0 plus W1 times A1, etc. For K attributes, we have K plus 1 coefficients. To simplify notations, we add A is to 0, that is always 1. Squared error. Sum through all instances, actual class value predicted 1. Deriving the coefficients. Minimizing squared error on training data using standard numerical analysis techniques. Matrix operations can be done if there are more instances than attributes, roughly speaking. In classification by linear regressions. Multi-response linear regressions, learning a membership function for each class. Training a perform a regressions. Create a model for each class, setting the output to 1 for training instances that belong to the class, and 0 for those that do not. In prediction, it predicts the class corresponding to the model with largest output value. Pairwise regression. It is designed specifically for classification. Training. Perform regression for every pair of classes, assigning output 1 for one class and -1 for the other. In prediction, predict the class that receives most votes. Output is greater than 0 from the regressions lines. More accurate than multi-response linear regression, however more computationally expensive. Thank you for watching.